everyone, my name is Mrs. Filer, and today we're going to be going over the lesson 13.5 in your Math and Focus book, which is talking about parallelograms, rhombuses, and trapezoids. And before we begin with that, I want to go ahead and just do some review with you to make sure that you remember some of the terms that you may have learned in 4th grade. So the first thing that I want to talk about is parallel. It's very, very important when we go through these classifications of what we call polygons that you understand what is parallel. So when you have two lines that are together, they are never going to intersect. These are called parallel. All right? So if you draw two parallel lines, they're going to continue forever. They're never going to meet. All right? So from the word parallel, you get the first type of polygon we're going to talk about today, which is called a parallelogram. Parallelogram. Parallelogram has 4 sides. 1, 2, 3, 4 sides. Each opposite side are parallel. So the sides are parallel and the top and bottom are parallel. So you will see here, this is a quadrilateral because it has 4 sides with 2 sets of parallel lines, top and side. Also, if you remember, each side is an angle. And an angle on the rectangle is 90 degrees. An angle on the corners of a square, 90 degrees. How many vertices, or the corners, does a square and a rectangle have? 4. And if you remember, if each angle in the square is 90 degrees, 90 times 4 is going to be 360 degrees. And that number is important because when we're trying to figure out the measurement of the angles, we're going to total 360 degrees. So we're going to be talking today about 3 different types of quadrilaterals. And we are going to try to figure out the angle measurement. We're not going to measure them. We're just going to use math calculations. For example, first one we're going to talk about is a parallelogram. I just explained the definition of that to you. 4 sides, opposite sides are parallel. Second one we're going to talk about is called a rhombus. Rhombus. A rhombus, 4 sides, all are parallel and equal in length. So if I measure this top side with the bottom, with the left side, they're all going to have the same exact measurement. Think of it as a square tilted a little bit. A square would have 4 90-degree angles. As you can see, this rhombus, they're not square. Think of it also as kind of a diamond. The last shape we're going to be talking about is called a trapezoid. A trapezoid. A trapezoid, again, it's got 4 sides, but only one pair of the lines is parallel. In this particular example, the top and the bottom are parallel. These 2 sides are not parallel, okay? If the lines keep going, they will what we call intersect, okay? So those are the figures that we're going to mainly work with. The other thing that we're going to talk about is when we do one of these shapes, each vertex has a letter. And that letter is going to correspond to an angle. So this may be referred to as figure A, B, C, D. it doesn't really matter where you start. It could be B, C, D, A, but I usually start, because it's letter A, I would start with letter A, okay? So this is letter A, B, C, and D. And I'm going to take this down. And now what we're going to try to do is we're going to figure out how do we find an angle measurement in a parallelogram. So here I have an example of a parallelogram. Again, this is going to be referred to as figure A, B, C, D. Okay, so I want you to just take a look at that particular figure here. See what you can find. We know that it's a parallelogram. Top and bottom lines are parallel. B and C, A and D are also parallel. Also, some of the descriptions of what I'm saying is down here. Like, for example, you remember that this little circle is the symbol for degree. When you see two lines together between the letters, it means parallel. When I have kind of this figure right here, that means angle. And the M stands for measurement. So we want to find out what is the measurement of angle C. So what it's doing is it's giving us the measurement for one angle first. In this particular case, angle B is 105 degrees. If you remember, we have acute angles, we have a right angle, and we have obtuse angles. So this is what's called an obtuse angle. So finding the measurement of angle C without measuring it is extremely easy. We know that angle plus the angle here, angle B plus angle C, have to equal 180 degrees. So I'm going to write that right here. The measurement of angle B plus the measurement of angle C have to equal 180 degrees. Okay? So what would I do to calculate what that particular measurement is? Okay? So I'm just going to take 180 minus what? 105. 105. 10 minus 5 is 5. This we had to borrow from. So 7. So this angle right here is going to be how many degrees? 75. Does that make sense? 75 plus 105, you can check your math, is equal to 180 degrees. Okay? The other thing in a parallelogram is what we call opposite angles. So look at this figure. Angle B is opposite to angle D. If I were to fold it in half, the angles would measure the same. So if this is 105, how many degrees is angle D going to be? 105. So I'm going to write that on my parallelogram. 105. Okay? So the measurement of angle D is 105 degrees. Well, what do you think is going to happen to angle C and angle A? Do you think those are going to be opposite angles? Of course. If this is 105, 105 plus 75 is going to equal 180. So this up here is going to be 75 degrees also. Okay? I hope that makes sense. Add this plus this to get 180. Add this plus this to get 180. And guess what? This plus this is 180. This plus this is also 180. So hint, totals of angles is 180 on parallel sides. 180 plus 180 equals 360 degrees. So all of our parallelograms, all of our quadrilaterals are going to have a total measurement of 360 degrees. Okay, so that's a parallelogram. Now let me put up the one with a rhombus and a trapezoid. Okay, so here we've got an example of a rhombus. Look at what a rhombus is. Remember, all sides are the same measurement, but they're not all 90-degree angles like a square. So it's tilted, okay? When you're calculating angles in a rhombus, opposite angles are equal. So if I know that angle F is 65 degrees, what do you think my angle H, which is the opposite angle, is going to measure? Think. What do you think? You said 65 degrees. You're absolutely correct. So angle H is going to be 65 degrees. All right? Now, angles E and angle G are opposite angles, but we don't know what that measurement is. That's what we need to calculate right now. So let's try to figure out the measurement for angle E, okay? So the measurement for angle E is going to be 180 degrees minus 65 degrees. So 180 minus 65 equals 115 degrees. So if angle E is 115 degrees, then what would the measurement of angle G be? The same, 115. So remember, when you're calculating the angles for a rhombus, opposite angles, and they're going to add up to 180 degrees. Okay? The last figure that we're going to be working with today is what's called a trapezoid. A trapezoid is, again, a four-sided figure. Top and the bottom, or two sides, are parallel. In this case, the top and the bottom are parallel, but these two sides are not parallel. So we're going to try to figure out what, remember, all four need to total 360 degrees. All right? So the trick for a trapezoid is the measure of each pair of angles between the parallel sides of a trapezoid have a sum of 180 degrees. So let me say that again. The measures of each pair of angles between the parallel sides, so that's angle K and angle L, need to total 180 degrees. So we know right here that angle L is 89 degrees. Angle K, I've already done the calculations here. So let's see. 180 degrees minus 91 degrees gets us 89 degrees. So the measurement of angle L is 89. 89 plus 91 9 plus 1 is 10, equal 180 degrees. Now, here you see a symbol that says NK is parallel to line ML. That helps you because you have to assume that they're parallel. Okay? Here they've also given us an angle of 130. Angle M is 132 degrees. So, would you know how to calculate angle M? Well, all you have to do is 180 minus 32 equals 48 degrees. And that's about right. It's an acute angle. So I hope that helps you in being able to calculate the angles of a trapezoid, a rhombus, and a parallelogram. Hopefully, in another lesson, we can go ahead and divide some of these trapezoids into half, where you would be able to calculate each half of the angles. If you have any questions, let me know. Otherwise, good luck on lesson 13.5 in your math book. Okay, see you next time.